Greetings and wishes. Welcome you all for the following the series of the video lecture. I am going to discuss in this video about combinational circuit, which is the second half of the digital electronics. So we are going to see what is meant by the combinational circuit and how it is going to be a part in the digital electronics that we are going to discuss now. So following the above things, we are going to see what is meant by combinational circuit. Before that, in the digital electronics, we are having a part called circuits, and in that we are having two parts. One is called as combinational circuit and another one is called as sequential circuits. Now we are entering into the circuit zone. Since we are going to design the circuit, we have to think about what is meant by a circuit and how to design that. So combinational circuit and sequential circuit. So what is meant by combinational circuit means, before that I will draw a block diagram like this. So consider this is a combinational circuit and it has two inputs and for example two outputs. Example. So what is meant by combinational circuit means the circuit that depends on present input only. So its output depends on the status of the present inputs one. Whereas if I want to think about what is meant by a sequential circuit, then what I have to do, I am going to draw the same diagram, combinational circuit. Along with that, I am introducing one new block that is called memory. So if I give the input, it will give output, and a part of the output is given as the is stored as the memory and it is given as a another input. So how to define the sequential circuit means the sequential circuit is one whose output depends on present input as well as past output. So the circuit whose output depends on present input as well as past output is called as sequential circuit, and this combination of combinational circuit and memory is called as sequential circuit. So with this inputs, what I am going to do is first we are going to see what is different things available in the combinational circuit. In that, first I am going to define what are all the things we are going to see in this video tutorial. Is first I am going to declare about what is meant by half adder and what is meant by full adder, and also I am going to discuss about mux, multiplexer and demultiplexer, and also encoder and decoder. And if possible, we will do one some conversion also, some binary to gray. So like that also we will realize. These four modules are very important to understand completely about what is meant by combinational circuit, how to design the combinational circuit, and how to realize the combinational circuit. These all things I am going to do. So here half adder and full adder we are going to discuss in this tutorial, and half subtractor and full subtractor I am going to give you as a assignment. So what is the thing is, assignment means it is not very hard. What you have to do is you need to just understand what I am doing here, and you have to do the same thing so that you will get the results in a very accurate manner. So it is very simple, no need of any expertise. So first I am going to take the topic called half adder. In digital electronics, what is the main important thing is, if I am assigning a task, for example, half adder means what means this combinational circuit, the combinational circuit that adds the combinational circuit that adds two single bit input and produces output as sum and carry. This is the definition. This is the sentence we are giving. The combinational circuit is one that adds two single bit input and produces output as sum and carry. So before that, what is meant by full adder? That also we will see. So full adder means what? Same thing. The combinational circuit that adds three single bit input. Single bit input. Out of this, one bit is the carry input. So this is the thing where we need to little bit concentrate. What is the carry input like that? So I am just drawing the blocks. So first I am having one half adder. Okay, half adder. So we are going to add. So present input, past input like that. And from this, we are going to take two things. One is called sum and carry. And again, what I am doing, I am going to pass this two inputs, and along with that, another input, another box I am taking. In that two inputs I am giving, and this carry also will be considered as the third bit, like this. Then it is called as full adder. But in the half adder, what it is doing, only it is having two inputs and two outputs. So it is not considering, even though third pin is available, we are not considering that, since third pin is dedicated for output from the previous any process. If any carries are available, means that you have to give here. So if a circuit is dedicated to the third input, that is carry input, then we are calling it as full adder. If we are not considering the carry input, then we are calling it as what? Half adder. Half adder. So half adder has two outputs. One is called sum and another one is called as carry. Okay. So what we are going to do now, I am going to, for designing any circuit, I am going to draw a truth table. That is very, very important. So that is the name why half adder, the name is coming, means it is going to add only half of the bits, only half. Out of three, we are not going to consider the third, only half of the bits are considering, half portion is considered. And it is producing output. That is why this is called as half adder. If you consider all the bits, then that is called as full adder, like that. Okay. So in that manner, half adder, meaning of the half adder, you need to understand. Half adder means not anything. It is not considering all the three inputs. One input is discarded, and only we are considering real two inputs. From the past outputs or any other process, that carry should come, that we are not considering. That's why this is called as half adder. So first we are going to do what is meant by a half adder here. So for designing half adder, how many inputs are there? Two inputs. I am calling it as A and B. And another two output, one is sum and another one is carry. So I am going to draw the truth table A, B. And then what I am doing, one is sum and another one is carry. Okay. So now I am going to write the truth table probabilities 0, 0, 0, 1, 1, 0, 1, 1. So if I add this, sum means you have to add these two numbers. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. And similarly, if you are adding these two things, any carry is coming or not, we have to understand. 0, 0 means 0, no carry. So 0. 0 plus 1 is 1, no carry. 1 plus 0 is also 1, no carry. 1 plus 1 is what? 1. But what I am having is 1 plus 1 is, if I am adding means, what I will get, 1 plus 1 is 0 and balance will be 1. So this is binary addition. Binary addition means 1 plus 1 is actually 2. If you convert that 2 means what I will get? 1 0. So 0 will be the answer and 1 will be the carry. So what I have to do is I need to put 0 and 1. Okay. So now after doing this, I am getting the truth table. From the truth table, what I have to do? I need to draw the Karnaugh map. Two variable Karnaugh map. Earlier lectures, we have tell many things about Karnaugh map. So here A and B, A bar and A, B bar and B. So how I am telling, what I am telling is A bar, B bar means 0, 0. Answer is 0, no need to fill. 0, 1, answer is 1. 1, 0, answer is 1. 1, 1, answer is 0. So what I am getting here, there is no pairs possible since diagonal combination that is not allowed in Karnaugh map. So what will be the answer? S is equal to this row and this column. So A bar B plus another is AB bar. So A bar B and AB bar is nothing but what? A exclusive, that is XOR. Similarly for carry, I need to do the same Karnaugh map. So A and B, this is A bar A and this is B bar and B. Here all are 0 except 1, 1 is nothing but 1. So carry is equal to what? Corresponding row and corresponding column AB. So now I have get the answers. S is equal to A bar B bar, A exclusive B, and C is equal to AB. If I want to draw the diagram, what I have to do? I need to take AB. XOR means XOR gate, and output is nothing but what? Sum. And similarly, carry means what? The same AB, and I need to put the gate and gate, that is nothing but carry. So these are all theory. Whatever we are discussing now, based on the definition, first I am writing truth table, and based on the truth table, I am drawing the diagram. So our theory part is over. Now what I am doing, I am going to realize this by using Python and Tinkercad. If it is coming means, then we will go to full adder, how to modify and what is the truth table, and based on that, next we will go ahead with the final part. Okay, so what I am doing is I am going here and I am taking this part. So better, instead of showing you a ready-made program, what I am going to do is I am going to take a new notebook that is called a practice sheet. So that practice sheet I will take and I will try to write the program in from a scratch method. So that we will do here. Okay, so let us think what is happening here. So right now what I am doing is, now I am going to take this reference. So first I am going to see what is meant by how to write this diagram into a program. So first I am going to write the program. How to write? Already in the earlier classes we already tell so many things. First I am going to start with the definition. Okay, before that I will connect this. So what I am doing, definition of a half adder. So I am writing a half adder definition. So this is user defined. How many inputs we are having? 2 inputs. One is A and another one is B. So what I am doing, A comma B. And then what I have to do, I have to keep colon. This is the basic scratch I am doing. So listen everyone. So after that, what I have to do, I need to write the definition for sum and carry. So what is the sum? Sum is equal to what? A cap B. Automatically, if connected means Gemini will give you all the things. No need to worry. So just press tab, the program is ready. Sum is equal to A cap B. First you need to verify whether this is correct or not. Carry is equal to what? AND gate. So A and B, and return sum comma carry as the answer. After that, what I have to do, I need to write the truth table. So for writing the truth table, what I have to do, I need to write print. So print half adder of that I don't want. I want to do some first one is A, second one is B, like that. So in order to do that, I will do this. I will take this part and I will do. Okay, so for your understanding, I am taking this. Okay, so here I am taking this part, but you can better you have to write all these things. For time conservation, I am just taking this part. So what I am doing, print off. So print half adder truth table, input is A, input is B, sum and carry, and then print all these things. Okay, and after that what I have to do, I need to write for condition. For condition means what I have to do, for. Okay, so here I am writing for A of 1:0. This part I have to write for A in 0,1. So different probabilities, right? So I am going to write like this. So for A of 0,1. For A of 0,1, for A of 0,1, you have to understand what is the probability what we are going to do. That you can check here. For A in 0,1, like that you have to write. For A in 0,1. For A in 0,1. And then press enter. And then if your code is correct, means the Gemini will automatically give you suggestion. Otherwise, you have to take care. So colon. Then automatically the code is generated, right? From that itself, you can understand whether we are going correct or not. If you are not giving correct instance, means colon, if I remove and press enter, means Gemini will give you suggestion, but it will take some little bit. So from here itself, you can understand what are all the things to be done. So if I press colon and press enter, automatically Gemini will suggest you what you have to do. So if I press tab, means what you are getting for B in 0,1, sum comma carry is equal to, I am calling this half adder of A comma B. If I am calling this, means everything will be done, and print A, B, sum carry. That's all. So what I have to do? I need to run this program. If I run this program, means what happened? Automatically you will get 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. Same thing, I think so. 1, 1, 0 and then 0, 0, 0, 1. Fine. So like that we have created the. Now I am going to realize this by using Tinkercad. So for using this, I need to know the IC numbers. So XOR gate is nothing but what? IC 7486. 86 is nothing but what? XOR gate. So I am going and taking and keeping. And one more, which gate is required? AND gate. AND gate is nothing but what? 7408. So I am taking 7408 AND gate. So I am taking here. After that, what I have to do? Normal connection. So first I will connect the power buttons and then I will do the rest of the connections. Okay. So power button is this. So I am connecting this to here. Okay. And then ground button. This is ground button. Touch and verify whether you are correct or not. Okay. So ground. So for instance, you can change the black color. This is red color. The main thing is the patience is very, very required. Why we need to change the color means then your circuit will not look that much attractive. So once you are doing all these things by patience, means definitely you will get correct result at the first instant. So without knowing anything, you can design your circuit. Now I am designing. Okay, so follow all these things. So black color. Now how the connections we are giving, you can see here. First AB to XOR gate. AB means what? You will give two switches, right? So what I am doing, I am taking this switch. Two switches required. Three switches I am having, but two switches is sufficient for half adder. So what I am doing, I am taking one wire and I am connecting to first pin of the XOR gate. First pin of the XOR. So This is input 1. This is input 2. It is input 3. So similarly, what I am doing, second pin I am taking one connection and I am giving it to, okay, I am giving it to second pin of the IC. Two pins. If you want, you can change the colors also. First color may be purple and the second color may be my pink. Like that you can change. It is your wish. You can do anything. Output, next third pin to what I am doing. Third pin is my sum output. So what I am doing from the third pin, I am taking one wire and directly connected to LED. And this LED, I am calling it as sum LED. So for understanding what I am doing, I am taking one node here and pasting here, and I am calling it as sum. This node, I can do anything. So, sorry, this is top simulation. So here I can write SUM, sum. This is XOR gate output is nothing but what? Sum. Next, what I am doing, carry. For carry, what I have to do, so first pin should be connected to first pin. So taking here and connecting here, right? And the second pin from here, this is second pin. I am connecting to second pin. And from third pin, I am taking one wire and connecting it to which pin? This one. That's all. My wire is over. Now you can see how the connections. Okay, no disturbance of anything, no cross wires, nothing. So from here, what I am doing, I am taking and just I am putting here and calling this as CARRY. Okay. So if I take this means, you will get whatever I am connecting, everything will be notified. Right. Now what I am doing is, I am going to start the simulation. So 0, 0 is 0, 0, 1. 0, 1 means what you have to get from the, here I will verify. 0, 1 means sum will be 1, carry will be 0. So what I am doing, 0, 1. You can see sum is 1, carry is 0. Similarly, 1, 0 means what you will get, sum 1, carry 0. Same thing only. 1, 0 means sum 1, carry 0. Finally, 1, 1 means what happens, sum 0, carry 1. 1, 1 means sum 0, carry 1. This is called it. Now what we have did, we just write a definition. From that we design one truth table, and from that we design one circuit. And the truth table is correct or not, and the circuit is working or not, we are realizing. That is how this realization is working. Once you start realizing all the circuits, means you have confidence that what I am doing is correct. Okay. So now I am stopping here. Now what I am doing is, I am going to the second part. What is the second part? Full adder. Full adder, first we will do the workout here. What I am doing, let us follow. So first I am going to write you what is meant by a full adder. Already we have written. So instead of 2 bits, it has 3 bits. Out of this, 1 bit will be what? Cin. That is carry from the previous process. And here also we are having 2 things. One is called sum and another one is called as carry. Right. And after that, I am going to write the probabilities 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. And then, so here I am extending. Sorry, my lines are jumbled. 1, 1, 0 and 1, 1, 1. So here what happens? 0, 0. If you add all these things, first you add 0, 0 and then 0, 1. So answer is 1, carry is 0. This also answer 1, carry 0. This is what? 0 plus 1 is 1. 1 plus 1 is 0, 1. This is 1, carry is 0. 2 ones are there. So 0, 1. Here also 2 ones are there. So 0, 1. And finally 1, 1, 1 is nothing but 1. So 1, how it is coming? 1 plus 1 is 0. balance 1. And if I add this 1 means what I will get? 1, carry is already 1. Okay. So 1 0 will come and another one is 1 1. So here sum is 1, carry is also 1. Like that you have to write. So this is the truth table. Now we have written and how to draw the Karnaugh map. That is important. So for drawing the Karnaugh map, I am going to take 3 variable Karnaugh map. For solving Karnaugh map, you have to watch my previous videos. So B bar, C bar, B bar, C, B, C, B, C bar, A bar and A. 0, 1, 2, 3, 4, 5, 6, 7. So here, which are all the things I am getting? 0, 0, 0. So 0, 1, 1 is 1, 2 is 1. 1 is 1, 2 is 1. 3, 0, 4, 1, 7, 1. 4, 1, 7. No pairing possible. So first I need to write all these things. So what is sum is equal to first this corresponding row and column. So A bar, B bar, C plus second is A bar, B, C bar plus A, B bar, C bar plus A, B, C. So plus A, B, C. Here I will write this plus A, B, C. Now, what I have to simplify all these things. Which one I can take output, I have to check. So here, A bar I can take outside. Remaining thing is B bar C plus B C bar plus A into B bar C bar plus B C. You all know that B bar C plus B C bar is nothing but what? B exclusive C and A into B exclusive C the whole bar. This is AX now. It is of the form A bar B plus AB bar. So once again I can write what? A exclusive B, which is equal to, this is of the form A bar, this entire thing is B plus A B bar, which is nothing but A exclusive B. So what I am doing, A I am taking, A exclusive I am taking, instead of B what I have to write? B exclusive C. So instead of C I have to write C. So this is equal to A exclusive B exclusive C in. So next one is I will form, which one is coming, I will form here. So 3 is 1, 5, 6, 7 is 1. 3, 5, 6, 7. So same Karnaugh map I am forming here. So A bar and A. This is B bar, C bar, B bar, C, B, C, B, C bar. 0, 1, 2, 3, 4, 5, 6, 7. So which we identify? 3, 4, 5, 7. Right? 3, 4, 5, 7. 4 is I think 5, 6, 7. Right? So 5, 6, 7. So this will not come. So I will erase this. The stroke register is so this is 0, 3, 5, 6, 7. How to pair this? So this thing one pair, this thing another pair, this thing another pair. So 3 pairs I am getting. What is the result of pair 1? Pair 1 is nothing but BC. And pair 2 is nothing but corresponding row and corresponding column. From this corresponding row is A, corresponding column is B and B bar cancel, AC. And here what is the corresponding row and column? C and C bar cancel. So I will get A. So what is the answer? C is equal to, actually here C in everything. Okay. So carry is equal to AB plus BC in plus AC. Is the answer. Fine. So how to draw the circuit now? A exclusive, B exclusive, C in. So what I am doing is I am drawing like this. First one XOR gate. From that I am getting another one is Cin. Sir, why we are not giving here itself means practically 3 input XOR gate is not available. So we are using 2 exclusive OR gates, but single IC is sufficient. This is sum. Carry is nothing but what? First from A I will take one input. From B I will take another input. Form one OR gate. Okay, and then BC in AC. So BC in means what we will do? B one input, C in another input, another AND gate. AC in. So from A one input, from C in another input. From here I will draw one thing. So these three things, what I have to do? I need to add together. I need to add together. That is by means of OR gate. So what you will get? Carry. This is the circuit. So how many gates we require? One XOR gate, one AND gate IC, and one OR gate IC. With that, we can able to realize what are all the things to be done. Actually, this is very somewhat what we call it as time-consuming process. So we will realize by using first we will start realize by using Python. So how to start realizing? This is very simple. I am just copying all the things. From scratch, you have to learn to write the program, whatever you want. So full adder. So full adder means what you will get? I will get one more term that is called Cin, right? So after that, what I have to write here, sum is equal to A exclusive, B exclusive. So if I put means automatically it will come. See here, Cin. And C out is equal to what? 1 minute, I will show you. Right, tab I. Okay, now it is coming or not? A exclusive, B exclusive, Cin. And C out is nothing but AB, BCin, ACin. So this carry is not out. So you can rename as carry also, no problem. Here I will name it instead of C out. This is suggested by Gemini, so I am changing myself. Carry. So here these are your wish. So here I am adding full adder truth table. And here what I will get? I will get one more thing that is called input B. Okay, input Cin, right? And then pipe symbol followed by sum and carry. And then for this A, B, this I have to extend further. Okay, one more thing I need to form here, that is on pipe symbol followed by some dash. So here what is the next thing we have to do? A is already over, B is already over. For Cin 0,1. So here what I have to do? Here instead of half adder, I need to call full comma adder. Full underscore adder. From here also you can select. Here I need to call the word A comma B comma Cin. So A comma B comma C. Same thing you have to place. And here also I need to add one thing, that is nothing but what? Within Cin, right? Cin, and then I need to give a space, pipe symbol, follow this. That's it. Your work is over. So here also some is there, some mistakes coming. We will see what is that mistake. So indentation error will come automatically. Okay. So if I press here means automatically you will get all these things. Better you can just press a tab and remove all these things so that unnecessary errors will be avoided. Right. Now the error is avoided. Now if I run the code means, yeah, you will get all these things 0, 0, 0. So whatever we have written, it is coming or not, just check 0. If any answers wrong also, you have to be careful. So 0, 1, 1, 0, 1, 0, 0, 1, right? 0, 1, 1. Check here. 0, 1, 1, 0, 1, 0, 0, 1. This is nothing but 3, 5, 6, 7. Exactly correct. Exactly what I am. So now I am going to do the things for you. That is nothing but what? This I will make a hold, since we have to realize full adder, right? So betterment, I will remove all the things so that you can easily understand. So XOR gate is required, AND gate is required, one more gate is required, that is called what? OR gate. 7432, that is OR gate. That also I am placing here. Next, right? So here also ground button is there, right? So that I am changing it to black color, and this one is nothing but my power supply. That is nothing but red. So first two pins are as it is XOR gate, and first we need to write the pin details for this. Since the circuit is somewhat complicated, so I need to write the pin diagrams. What are all the pins to be used, that I will write here, right? So here I will write, this is pin number 1, pin number 2, pin number 3, and this is pin number 4. Pin number 3 is my output. So this is pin number 4 is my input, pin number 5 and pin number 6. That's it. And similarly for AND gate, 1, 2, 3, 4, 5, 6, and then 7 is ground. So 8, 9, 10. This is 8, this is 9, this is 10. Okay, we will see why it is. And then for carry, 3 input OR gate is given. 3 input OR gate not available. So what I am doing is I am just taking 2 input OR gate, 1, 2, and then 3. And then instead of 3 input OR gate, I am doing this alteration. One more OR gate, we will check whether the Tinkercad is having that provision or not. Otherwise, we have to go with this. So this is 4, this is 5, and this is 6. This is temporary arrangement. First, we will check whether 3 input OR gate is available in IC 7432 or not. We will check. So OR gate. So OR gate is nothing but here. So 3 input quad OR gate, quad NOR. This is 3 input NOR gate. So 3 input OR gate is available or not, we need to check. So we will type triple. Okay, so you will then able to get triple OR gate. No, it is not available, right? Triple. What are all the triple available? Triple NOR gate is available. Triple input, 3 input AND gate is available. But 3 input OR gate is unfortunately not available in the Tinkercad. So you have to go with this design. There is no counterpart. Just for temporary purpose, I drawn here. So I will remove all these things and I will do what are all the things to be done. Okay. So 3 input OR gate is not available. So how to do this means from AND gate, I will take 2 inputs. And first I am giving it to one OR gate. From this I am taking one output, and following that from here I am taking one more thing and giving it to another OR gate. So this is my carry. So this is 4, this is 5, and this is 6. So for shorting this terminal is very, very important. So first we will do it 1, 2, 3, 4. 3 and 4 should be shorted. 5 is the direct input, 6 is the sum. That I will do here first. So what I am doing is I am going here. So from the third input, what I am doing, I am taking one wire and giving it to third pin or fourth pin of the end. Since third pin is the output, right? Here you touch means you will get the information. Third pin is output, fourth pin is the input. So here I am giving. So what I am doing is fifth pin, or we will check. Fifth pin is the input, right? So what I am doing, I am instead of fourth pin, I am just shifting this to fifth pin, right? And this is seventh pin is ground, connecting here, right? And then here also seventh pin is ground, and this one and this one are already connected. Fine, right? Now what I am doing is I am going to short third pin and the fourth pin, shorted. Fifth pin is the input, and from the sixth pin I am taking direct wire and giving it to some connection. Okay, so one bit I will shift out, right? This is over. So, some portion is over. Some portion is over. Carry portion I need to check it out. So that is somewhat difficult. So 1, 2 is given to first two AND gate and these things. So better what I can do is I will do from here. So first pin of the AND gate. Okay, so first pin of the AND gate should be connected to first pin of the XOR gate, right? And similarly, second pin of the AND gate is connected to second pin of the XOR gate, right? And then what I am doing, third pin. Now here you can check. Third pin is connected to first pin of OR gate. So third pin is connected to first pin of OR gate, right? OR gate. And then fourth pin and fifth pin, what it is having, we have to see. Fourth pin and fifth pin are connected to which pin, we have to check. Fourth pin to second pin, fifth pin to fifth pin. Fourth pin to second pin, fifth pin to fifth pin. So let us check here. Third pin is over. So fourth pin is connected to second pin, right? Fourth pin to second pin. So what I am doing is I am taking this and I am connecting it to second pin is already connected with somewhere, no? So you can use that. So second pin, 1 minute, I will tell you the secret what you have to do. This second pin is already connected with second pin of the XOR gate. And here what I am doing is second pin is once again connected. We have to connect it with what? Fourth pin. Second pin is once again we have to connect it to fourth pin. So second pin we have to connect to fourth pin means what I have to do. So XOR gate second pin, any provisions are there? Yes. And we have to connect it to fourth pin of the IC. We have to connect it to fourth pin of the IC. So this is fourth pin. And fifth pin should be connected to fifth pin one, direct fifth pin to fifth pin. So any provision here for fifth pin? Fifth pin. This is sixth pin. This is 4, 5. This is fifth pin, right? So from the fifth pin, I will take one wire. So how connections become complicated when we increase only one gate. You have to just see that. So fifth pin should be connected to fifth pin. So if you understand this logic means directly you can design any circuit. Digital electronics, this connection once you understand, that is the major thing. Fifth pin to fifth pin. Okay, so fifth pin to fifth pin obtained. Now what I am going to do is sixth pin to second pin, that we have to do. So sixth pin to second pin of the OR gate. Sixth pin to second, right? And one more choice is what? Last 8, 9, 10. We have to connect. So ninth pin to first pin, 10th pin to fifth pin. Ninth pin to first pin, 10th pin to fifth pin of the XOR gate. ninth pin to first pin. Okay, so ninth pin to first pin means what I have to do here. You need to touch and check. So output, this is 8, 8, 9, 10. Okay, so what we have tell ninth pin to first pin. So what I am doing is from the ninth pin I am taking one wire. Ninth pin I am taking one wire and giving it to fifth pin of the IC. Fifth pin of the XOR gate. So fifth pin of the XOR gate means 1, 2, 3, 4, 5. Fifth pin of the XOR gate means out of these three I can touch anywhere. So I will touch. So now you can see the cross wires are coming. Okay, so that you can by means of patiently you are now I am teaching online, so I am frequently connecting. So if you are very simply you are designing in a very systematic manner means these wires will be like somewhat like fascinating that you have to make out. So from 10th we have to give it to 5th pin. Sorry, I mess up one thing. So 9th pin to 1st pin and 10th pin to 5th pin. Okay. We can change it also. 1st pin we need to connect, right? 9th pin to anything we can connect. 1st pin also you can interchange. So better what I am doing is from here 10th pin, right? 10th pin to 1st pin I will. So 10th pin I will take one wire and connect it to 1st pin of the XOR gate. The 1st pin provision available, that is very important. So available, so first, right? And after that, what is the remaining task? So 1st pin, 2nd pin, 3rd pin to 3rd and 4th pin should be short. So here also 3rd and 4th pin is shorted. And from 8th pin, I have to give it to, okay, sorry. So how jumbling it is happening, right? We have to very careful. So from 8th pin, I am taking one wire and giving it to 5th pin of the OR gate. You can see here 5th pin of the OR gate. So 6th pin should be connected to this carry. 6th pin should be connected to this carry. So this is the connection. So I don't know. This is looking like somewhat jumbled. So we don't know how it will work. So these are 111. Fortunately, 111 is working. So frequently we will check 110. Okay, 110 means I will make it as 0. So carry is 1, 0, carry is 1, sum is 0. Correct? And randomly we will check 0, 1, 1. So sum is 0, carry is 1. 0, 1, 1. So 0, 1, 1. Sum is 0, carry is 1. 0, 1, 1. Sum is 0, carry is 1. 1, 0, 0 we will check lastly. So 1, 0, 0. Sum is 0, carry. Fortunately, first attempt itself with that of jumbled connections also we are getting correct results. That is experience. Okay. So when you are doing the circuit like this and patiently you connect means you can realize any circuit and you can verify whether the circuit is perfectly working or not. This is the power of designing. So in this lecture you have understand how to write a Python coding for full adder and half adder, as well as you have designed both circuit, both full adder and half adder, and you have learned how to implement this by using Python and your Tinkercad. So following this, you are having one assignment. That assignment is nothing but full adder, full subtractor, and half subtractor and full subtractor. That I am giving you as a assignment. So what you have to do is follow the same technique what I am doing, and first you have to write it, implement it in Python, verify the truth table, and realize all the program in Tinkercad so that you can understand what is in full subtractor. Full subtractor has 3 inputs, half subtractor has 2 inputs and 2 outputs. One is called difference and borrow. Difference and borrow. So what is full subtractor and how it is working, you can self realize and submit the assignment by you. So with that I am stopping. Thank you very much for listening my lecture. In the upcoming series we will see about what is meant by multiplexer, demultiplexer, encoder and decoder we will see. So thank you very much for watching my lecture. We will see you in the upcoming lecture soon. Thank you.